So this is the one that I want you to pay extra close attention to if you're trying multiple versions of this problem in this file. Right triangle always causes a little bit more trouble because we think, oh, it needs a 90-degree angle, and then we're not sure how to get that, and then we try to do something with the sides, and maybe it works, and maybe it doesn't. So when it wants you to know a right triangle, it obviously means there has to be a 90-degree angle, but we can't get that off of the graph. What we can get is perpendicular lines, all right, from the slope. So I'm going to have to make sure that I'm really careful with this, and I think about what kind of slope make perpendicular lines. So let's draw this thing first, and then let's put the little chart together, and then we'll talk about what has to happen. So 1, 7. So let's count these. So 1, 2, 3, 4, 5 positive. 1, 2, 3 positive. 2 positive. 1, 2, 3, 4, 5, 6, 8. And 1, 2, 3, 4, 5. And that's negative 5. It's going to go up. So I got those things right there for the slope. So I'm going to come over here. So I've got BM, MN, and I've got BM. Okay, so my slopes are rise over run. So BM is rise 5, run 3. MN is rise -8, run 2. And BN is rise 3, run -5. Okay, make sure that you get the rise on top and the run on the bottom. It's very easy to get those two mixed up, and then you have a whole 5 different problems. So 5 squared plus 3 squared equals c squared. And again, I didn't reduce any of my slopes, so I don't. I can use those numbers in my Pythagorean theorem. Let's see, that's 34. So square root of 34. And then 8 squared plus 2 squared equals c squared. That's 68. 4 to 68. And 3 squared plus 5 squared equals c squared. Square root of 44. Okay, now, those are the same for which isosceles, but it didn't ask that. It says it is a right triangle. So think about what perpendicular slopes look like. Okay, perpendicular slopes where you took a fraction. So I'm just going to put an example down here. And to make a perpendicular slope, you flip the fraction over and you made it negative. So what I want to do is look at these slopes and see if that happens between two of them. And if you look at this one, and then you look at this one, all right, those slopes right there are definitely flipped over, and they are also definitely opposite sides. So those two slopes form perpendicular lines. That means this is a right triangle. So I say based on my calculations, triangle BNN is a right triangle because it has perpendicular sides. And that's enough. You can be fancier with the words if you want to. But that's the basic idea of what you have to have. Right triangles are probably the worst ones just because we don't remember what we have to do to show that there's actually a right angle there. So make sure you take a little extra practice with this kind of a triangle right here so that we understand what's going on.